This question is about the halogens. Write the state symbol for chlorine at room temperature. Now, this has to be a gas, okay? Because halogens will be gases at room temperature, except for bromine, which is a liquid, and then iodine, which is a solid, okay? Now, your answer for this one is going to be a gas. Now, this is just one of those facts. It's one of those facts that you just need to remember, okay? And it goes as follows. All right, now let's go for question 4.2. Figure 4 represents one molecule of fluorine. Complete the dot and cross diagram on figure 4. You should only show the electrons in the outer shell, okay? Now, whenever you see a Venn diagram, okay, always have a look next to it, and if it's got marks, you definitely have something to do, okay? There's a lot of the time that students would just ignore the diagram because they just think it's general information, okay? But when you look on the side and you see those answers, those marks there, you definitely need to do something about it, okay? Now, so this only shows you the last shell, but we know that fluorine is in the second shell, so fluorine really and truly should have two shells, one in the middle, and then the one that is being drawn is the last shell, okay? So I repeat, fluorine, okay, should have two shells because it's in period number 2, but in the Venn diagram, they won't show you the first shell. They will only show you the last shell. They are only interested in the electrons that are in the last shell, okay? So only shows electrons in the outer shell. That's the reason why that is in there, okay? Now, it's important also that you remember that when you see a Venn diagram like this, we are looking at covalent bonding, okay? And another way of figuring out that this is a covalent bond is that we have a non-metal bonding with another non-metal. Non-metal plus non-metal gives you a covalent bond. All right, so let's get to the crunch of it. Now, both of them are in group 7. Both atoms are in group 7 because they are both chlorine, which means that they all have 7 electrons in their outer shell. However, because it's covalent bonding, they're going to be sharing one of those electrons. So if I just do that to this, there you go. That's the one electron that is sharing. Then you got 1, 2. Those are the 7 electrons in the outer shell of fluorine. And then you have to do the same thing for the other one. That is the electron that is sharing. So now 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You have drawn them. But in a covalent bonding, the atoms will share their electrons. So if we cover this part here and we assume that that circle electron is part of this fluorine, that fluorine now has got 8 electrons in this outermost shell. And if we do the same for the other side, this fluorine will also have 8 electrons in this outermost shell. All right, so now we go to the next question, which is question 4.3. Right, so it says here, a fluorine atom can be represented as 19,9F. What is the total number of electrons in a fluorine molecule? F2, okay? So this is immediately telling us that there is 2 fluorine atoms, okay? You got 2 of those in there. You got 2 fluorine atoms. Now, they want you to find out what is the total number of electrons in the fluorine molecule. A fluorine molecule is made of 2 atoms, so we need to figure out what is the number of electrons in one atom, and then you'll be able to tell what is the number of electrons for both of them because you just got to times it by 2. Okay, so let's have a look. This is how it's represented. Now, what we got here, okay, that will be your atomic mass number. So that'll be atomic mass, and that is the number of protons plus the number of neutrons added together. Now over here, what we have is the atomic number. And this here is the number of protons that an atom has. But also remember that an atom doesn't have a charge. But why doesn't it have a charge? Well, it has the same number of positives and the same number of negatives. So when they cancel each other out, the overall charge of that atom is going to be 0. So if it's got 9 positives, it must also have 9 negatives. So this fluorine atom has 9 electrons. But because a fluorine molecule is made with 2 fluorine atoms, just like we see in the example above here, then it must also have 9 times 2. Okay, so you must also have 9 and 9 and 9 times 2. It must be 18. So your answer has to be 18. Okay, so let's keep it moving and let's go to the next question. Question 4.4. Aluminium reacts with bromine to produce aluminium bromide. So let's see. So we have aluminium, which reacts with bromine to produce aluminium bromide. Now, I always tend to do this because it makes it easier for me to visualize what I'm doing. When I look at the word equation, aluminium plus bromine, aluminium bromide, is a lot easier for me to identify what's going on than rather just reading it from a sentence, okay? Complete a balanced chemical equation for this reaction. Okay, now, what I tend to tell students is that if you are not really good at balancing equations, I suggest you leave it and you come back at the end, because the majority of the time you will have 1 mark or 2 marks. If it's going to take you 5 to 6 minutes to balance an equation and try to get those 2 marks, you're going to be wasting a lot of time, okay? And most of the time it probably end up being wrong anyway, okay? So if you have a question like this and you're not really keen on it, you're not very sure about it, then you need to go and then you need to tackle it right at the end, okay? So we're going to do this right now. First thing that I do is we got to count how many atoms we have in each side. But before we do that, bromine, aluminium bromide. Now, aluminium is always going to have a charge of, when it becomes an ion, it becomes a charge of +3. Okay, so this one here is going to have a +3. Now, bromine has only got a charge of -1. So how many bromines do you need with a -1 to cancel that aluminium 3? So the number for BRs that you're going to need is 3. So your formula, so that will be -1, -1, and -1. So those 3 negatives cancel that out. Now you have the actual formula for aluminium bromide. We can start looking at the equation itself, okay? So what we got here is that it says here, they're already giving you this balancing. Now you need to figure out the balancing on the other side. So what I normally do is that I do the, I tend to do the hydrogens, oxygens, and then I do anything else. In this case, you don't have either of them. So we just have a quick look over here. Aluminiums, bromines, aluminiums, and bromines. Okay, so in here, in this side, because this number is here, it's going to multiply that 1 aluminium times 2. So you got 1 times 2 equals 2. Now over here, you also have the bromine, because bromine is also part of that molecule, is also going to get multiplied by 2, but you have 3 bromines in there, okay? 3 bromines. So that means that 3 times 2 equals to 6. So we got 6 bromines and we got 2 aluminiums in this side of the equation, okay? Now just to not get you so confused, well, I've already done that, I don't want to just do it again. We'll leave it like that. I was going to do that in red because that is one of the marks. And then over here we need to get 2 aluminiums because you got 2 in that side. So one multiplies one number multiplies 1 aluminium, that makes it 2. So that's pretty easy. If you have 1 aluminium, you times it by 2 and that's going to be 2. So in there we need to write, this one I'm going to do in red, okay? So there has to be a 2. And then what number can you multiply 1, because we got 1 bromine to make it into a 6. You times it by 6 and that's going to give you 6. So your answer for the is going to be 6, okay? So that's the equation balance for you right there. Sorry, I made a mistake over here. Just realized you don't have 1 bromine over here. You actually have 2 bromines because you got that there, okay? So one number multiplied by 2 is going to give you 6, and that is going to be 3. All right, so your actual answer for up here is going to be 3. Yeah, just made a quick mistake. Even the pros don't do it. So that's why it's very important as well that once you finish your exam and you have spare time, go through your answers again, read your answers just to make sure they make sense. You could make a simple mistake like this. It doesn't mean that you don't know how to do it. It just means that you made a mistake, okay? So that is your answer for question 4.4. Now let's go to question 4.5. Question 4.5. When chlorine reacts with potassium bromide, chlorine displaces bromine. Okay, so we got the chlorine over here, and then you have the potassium bromide, then the bromine end up by itself, and then you have potassium chloride, which means that what happened here is that chlorine has displaced the bromine. So potassium chloride has been formed over here, and then the bromine just ends up all by itself over there, okay? And the question says, explain why chlorine is more reactive than bromine. So we got 3 marks in here, so we got to talk about what's happening here. So this is very simple. What we got here is, let's just have a quick look at the bottom. Just gonna do a quick diagram. So we have chlorine, okay? Chlorine is in group number 3, so it should have 3 shells. There you go, and there we go. And the number of electrons are going to be, because it's got 7 electrons in the outer shell, it has a configuration of 2, 8, 7. Okay, 2 electrons in the first shell, 8 in the second, and then 7 in the last one. Now bromine is in group number and period 4, sorry. So it's gonna have 4 shells. 1, 2, 3, and 4. Okay. Now for the purpose of GCSE, we're just going to do the outer shell of bromine. So we should have 1, 2, 3, 4, 5, 6, 7. There we go. So what we got to take in mind here is that the reason why chlorine is more reactive is because the distance between the positive, because this is where the possible electron that is going to gain is, okay? So the distance between the positive center and the electron in the outer shell is the distance is less. Now in bromine, the distance is a lot further away, okay? And that's the reason why chlorine can attract electrons with a lot more efficiency than bromine, because the positive center is closer, so it can attract them a lot faster. It's like putting 2 magnets. The closer they are, the more they're going to be attracting each other, okay? So what we got to look at this is that chlorine has only got 3 shells and bromine has 3 shells, so that could be 1 mark in itself, saying that chlorine has a smaller atom because it has less shells. Then the next thing that you can say is that the chlorine can attract electrons because it has less shells in between the positive center and the last electron. Therefore it attracts electrons with greater strength, and therefore it can gain electrons a lot easier than bromine, okay? That will be your 3 marks. So now we just need to write it down in actual words. So mark number 1, 2, and 3. All right, so there you have it. That is question 4.5. Chlorine has a smaller atom with only 3 shells. There is less electron shielding between the positive nucleus of chlorine and the last outer shell. Then chlorine can attract electrons due to greater attraction, and chlorine can gain electrons easier. That will be your 3 marks over there, okay? So there you go. Thank you very much for watching the video, and if you want to carry on with this and look at question number 5, click on the following video. Peace. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.